An exam question here on equilibrium, finding Kc, so from an experiment, and we're doing a titration in order to do so. So let's just examine the question for a bit. So first of all, we see we're given grams of our two reactants. So in a minute we're going to have to turn those into moles. So we're mixed in a stoppered bottle. So why are they telling us stoppered bottle? That's just to say that it's a closed system, and so it's going to reach a dynamic equilibrium. Left for several days to reach equilibrium at room temperature. Okay, and at the end of that time, mixture is poured into pure water. Okay, so poured into pure water. That is quenching. So that is quenching. It just stops the reaction at that point, so that you can do your titration on it, and as you take your samples, see how you're taking 25 cm cubed samples out of your 250. Each of your 25 cm cubed samples have got to be the same. You can't have the equilibrium changing. So you quench it to stop the reaction and keep it there. Normally you would say pure cold water, actually, because that would be slightly better practice. Anyway, so you're quenching it to stop the reaction, and then you're making it up to 250. So you're making it up to 250. So let's draw a little volumetric flask. So there's our volumetric flask, and you've made it up to 250 cm cubed, right? But each time you do a titration, you're just going to take 25, and so we have to remember to multiply back up by 10 to work out the moles in equilibrium. So there we have that. Let's see if there's anything interesting here. Okay, so with the titrating with sodium hydroxide. So sodium hydroxide, and it's a neutralization reaction. Okay, so this is a separate reaction. The reaction we're given here is the esterification reaction. This is the equilibrium reaction, right? But the titration reaction is a different reaction. That's taking a sample of the equilibrium mixture, and actually only the acid, right? So you've got in that equilibrium mixture, you've got your ethanoic acid, you've got your ethanol, you've got your ethyl ethanoate, and you've got your water, all in the equilibrium mixture. But only the ethanoic acid is going to react with the sodium hydroxide. Okay, so that's the titration reaction that's happening, in the volume in the conical flask. And so we're given the concentration and volume. So here's our titrate, here's our volume of sodium hydroxide, here's our concentration of sodium hydroxide. So we're given everything about sodium hydroxide, and so we'll be able to find from that titration the amount of ethanoic acid at equilibrium. That's why we're doing that titration there. Okay, so last thing to think about is that we're being asked for Kc. So what we're going to have to do is we're going to have to find the concentrations of the reactants and the products at equilibrium. That's what we need in order to find Kc. In order to find the concentrations at equilibrium, we're going to have to find the moles at equilibrium. Okay, so moles at equilibrium. That makes us think about our little spreadsheet. Okay, so we're going to have let's draw a little box here. That's going to be our moles of ethanoic acid at the start. All right, moles of ethanol at the start, moles of our ester at the start, and moles of our water at the start. So this is moles at the start. We're going to put all those four in there. And if you remember our spreadsheet, we work out reacting moles, and we work out equilibrium moles, and then after we've got equilibrium moles, we can have equilibrium concentration. And from that, that's what we need for the four components to work out Kc. All right. Right, so I'm just going to draw a line down here because we're going to do our calculations on the right hand side there. Okay, so we're going to go back to the start. We're going to work out moles of ethanoic acid. right? And that's going to go into this box here. All right. So moles of, let's call it EA to save us a little bit of time. Moles of ethanoic acid, it's going to be, we've got a mass, so it's going to be mass over MR. So our mass is 24 grams, and our MR of ethanoic acid is 60, I think. Yeah, 60. And so that's 0.4 moles. So 0.4. Let's leave it at 3 significant figures because our data is at 3 significant figures. So we can put our 0.4 in here. Right, we're going to do the same for ethanol, right? So we're going to fill in this box here now. So our moles of, let's call it ETH, that is 23 grams this time, and our MR of ethanol is 46. All right, so we've got 0.500 moles of ethanol, so we can put our 0.5 in here. And it's at start, so we've got no moles of either of the two products. Okay, so that's that. Now we're going to have to look at the titration data to work out how much ethanoic acid we've got at equilibrium. Okay, so we've taken a little 25 cm³ aliquot of the equilibrium mixture that's been quenched. Quenching doesn't change the number of moles, and we're only interested in moles, so that everything's fine. So let's consider our titration reaction. We've got some sodium hydroxide. We've got some sodium hydroxide. That's what we've got in our burette, and we've got the equilibrium mixture in the conical flask. But the only thing that's reacting in the equilibrium mixture is our ethanoic acid. So let's draw our ethanoic acid. CH3COOH, right? So they react. It's not an equilibrium reaction. This one, that's a normal neutralization reaction, and you're going to get salt, which is going to be sodium ethanoate. So CH3COONA is our salt, and we've got some water as well. So that's our titration reaction. That's the neutralization reaction, and we're told all the details about sodium hydroxide, aren't we? And from the balanced equation, you can see that 1 mole of sodium hydroxide reacts with 1 mole of ethanoic acid. So if we worked out the moles of sodium hydroxide, that would tell us the moles of ethanoic acid that were present at equilibrium, at least in the 25 cm³ aliquot. Okay, so moles of sodium hydroxide in the titration is concentration times volume. Concentration from the question is 0.4 moles per dm³, and our volume, which is the titration, is 26.5. But we just convert that to our dm³, and so our moles of sodium hydroxide is 0.0106. 0.0106, that's what that works out to be. Now, so that's that, and that is the same as the moles of ethanoic acid in the 25 cm³ aliquot, but the moles of ethanoic acid in the whole 250, which is the equilibrium amount, is going to be 10 times that. So moles of ethanoic acid at equilibrium, EQBM, right, is going to be 10 times that, because that's 250 divided by 25, yeah? So 10 times 0.0106, which is 0.106. So that is this number here that goes in here. So we have 0.106 in there. Okay, so let's see what else we can fill in our spreadsheet. So that if we started off with 0.4 moles of ethanoic acid, we ended up with 0.106 moles, then the amount that reacted must be 0.4 minus, right, our 0.106 equals, so how much reacted? So 0.4 take 0.106, that's 0.294. but it's reacted away, so we're going to call it minus 0.294. And 1 mole of ethanoic acid reacts with 1 mole of ethanol, so ethanol is minus 0.294 as well. And for every mole of ethanoic acid that reacts away, we make 1 mole of ethyl ethanoate. All right, so that's going to be plus 0.294, and the same with water, plus 0.294. Okay, so now we can fill in all our equilibrium moles. So starting off with ethanol, 0.5 take 0.294 is this number here, which is key. So 0.5 take 0.294 is 0.206. And moving on to the ester, so we got 0 plus 0.294 is 0.294, and the same for water. Okay, so now we've got all the equilibrium moles, which is the difficult part of the job. Now we just have to convert those into concentrations and then use those to work out Kc. Okay, so concentrations first, starting off with ethanoic acid. Concentration, of course, is moles over volume. So let's call volume's going to end up cancelling out because look, you've got the same number of moles left and right. So volume will cancel out. But so let's just call it V for now. So we've got 0.106 over V. We've got 0.206 over V. We've got 0.294 over V, and we've got 0.294 over V there. Okay, so quickly now we can do our Kc. Kc is ethyl ethanoate, which is 0.294 over V times our water, which is also 0.294 over V. That's all divided by the product of the two reactants. So we've got 0.106 for ethanoic acid, and the concentration of ethanol is going to be 0.206 over V. So let's just cancel out our V's. Those two cancel out, and those two cancel out. And then you're left with just the numbers, and so you work out that Kc comes out 3.96. All right, and there are no units because all the units cancel out because there's the same moles on both sides. Just like the volumes cancel out, the units cancel out as well. And there's Kc, which is what we were asked for in the question. Hopefully that's been clear.